396, 12 through 48, multiple, not 12, sorry, 4. I'm thinking 12 questions, but it's not 12. It's 4 through 48. Multiples of, anyone know? 4. Ah, you guys are smarty pants. Okay, so again, POC people, your homework for this lesson is going to be done on paper, not on WebAssign, and this is the assignment. There are 12 questions, 12 graphs. It's not really that helpful to have graph paper, but if you want to, you can. So write that down, and then I can move on to bigger and better things. Oh, Hunter, you don't have to write it. I already sent it to you. Funny one?
Sorry.
Okay, can I go on the next screen? You guys got it?
Sorry, force habit.
Whoa, what's with that linear?
Can I
Yes.
advance? Thank you. Okay, so graphing sine and cosine. Sine and cosine.
What class would this be?
This is 5.4. No, 5.3. It's 5.3, I believe. We did 5.1, 5.2, 6.1, 6.2, 6.3. Now we're back to 5.3 and 5.4. And then we'll go back to 6.4. We're just going to be hopping around like little kangaroos. Okay, graphing sine and cosine. Excuse me. This is where things get tricky for you. I warned you this day would happen. What's happening is that you're used to seeing sine as the y-coordinate, x is the cosine, and blah, blah, blah. Right now, you can't think of x and y as the x and y coordinate. Okay? Just think of x as input and y as output.
They're variable.
Does that make sense? They're just variables. So it is still true that the sine is the y-coordinate, but in this case, we're just going to throw in a bunch of angle measures. Those are always the input. The input is always angle measures. And the output is going to be the y-coordinate, okay? But you could also do this. Y equals cosine x. And that one gets really funny because, wait a minute, I thought you said y was sine. It is. And x is cosine. It is. But again, input, output. Just think of it that way. Input, output, not x, y.
We use just A and B.
No. You have to get used to this because all of your book is going to be that way. So if I do a different letter now to make it easier for you, you're going to go to the homework and be like, change the letters. You have to just get used to it. Okay? X and Y just means input, output. Okay, so you will notice that when you graph for trigonometry, you're going to want a really long, normally when you make a graph, you make a nice little even, your X and your Y are the same length. You don't want to do that. With sine and cosine, you kind of want to be like this. Your y-axis can be kind of short, but your x-axis is going to be really long. Okay? Because the sine curve is going to be like, woo-hoo. In fact, when you think about a sine curve, think of a slinky. You guys know what a slinky looks like? It's like round. Like if you had the slinky all closed, like it's not like stretched out, and it's all closed, and you're just looking down at it, it's just going to look like a circle. Right? Like a unit circle. And then when you pull it apart, it's going to be looking like this, right? Like in front of you, like if you pull it apart like a little accordion, it's going to be looking like this. That's exactly what sine and cosine look like. It's like you take the unit circle and just kind of spread it out, okay? Because the slinky is a perfect example because of rotations. You know how the slinky is tall, right? Because it has all these it's just stacked on itself, but it's rotate, 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 circle, circle, circle. And when you go like this, you expand it all and it looks like, right? It's periodic, which means it repeats itself over and over and over again. So you're going to be asked to do 2 periods, okay? So for example, that's 1 period. That's another period. And it's going to keep doing that. So that's 3 periods now, okay?
Periods
so
of the hills.
The period is how long it takes the graph to make 1 complete revolution around the circle, which we know is 2 pi.
So the hill.
Correct? So this is 2 pi. This is 4 pi. This is 6 pi.
Basin.
On a unit circle, don't worry, Mark, it's okay. You start here, this is 0. The angle measure is 0. The angle measure is the input. So 0. 0 angle measure. What is and we're doing sine here. So we're only going to graph the y values. So we're gonna do 4 points. Uno, dos, tres, cuatro. That's why graphing a sine curve is really easy, because we're not gonna do all the in-between stuff. All you need is these 4 points. Technically 5 if you go back to 2 pi. 0, pi over 2, pi, 3 pi over 2, 2 pi. But we know that 0 and 2 pi are the same thing, right? So if you go all the way around the circle, there's 5 points of interest. And each curve goes through them in a systematic way. Sine curves always start at 0, max, 0, min, 0. 0, max, 0, min, 0. 0, max, 0, min, 0. It always goes through that pattern. A cosine curve goes like, no, let's see if I can do this now. It's kind of a shifted sine curve. It starts at its max, 0, min, 0, max. Always. A cosine curve will always start at its max and end at its max in one period. The sine curve will start at 0 and end at 0 in one period. Now you guys know what's going to happen, so we have to get careful here. We're going to do a basic curve, but then like before, you can shift them. You can go up, down, left, right, fat, skinny, whatever. All that stuff can still happen. But this is the basic curve. We want to graph the basic curve before we go anywhere else, right? So I'm going to do this again, but it has up here. So I'm going to go through the points really quick for the sine curve first. That's the black one. When the angle of rotation is 0, so you haven't rotated anywhere, what is the y coordinate? Okay, that's the sine, right? The sine is the y coordinate. So what is the y coordinate at this point? 0. So that's why you're plotting 0, 0. The input is 0, the output is 0. The next point of interest is pi over 2. What is the y coordinate here? 1, right? So when the input is pi over 2, which is right here, the y coordinate is 1. And that's the max, right? It's the highest value that the sine curve will ever have, right? And then you're going to go to pi. What is the y coordinate here? 0. So at pi, you're at 0 again. So you see you're going there, okay? And then the next one is going to be 3 pi over 2. And the y coordinate there is -1. So at 3 pi over 2, you're over here. That's -1. At 3 pi over 2. So that's that guy right here. And then lastly, you're back at 2 pi, and you're back at 0 again. So 2 pi, 0. See? And then it happens all over again. Right? You can keep going. 2 pi, right? So what's this going to be? 5 pi over 2? 7 pi over 2? 8 pi? And you're just going to, well, not 8 pi, 8, 4 pi, right? You're just going to keep going around and around we go. But the same pattern is going to happen. So generally, we're going to ask you to graph 2 periods. So you're not going to graph it forever. Technically, you can graph from the negative side to the positive side. But we want to start with 0 always because it's just easier that way. It's easier to grade if everyone does it the same way. Okay? So now cosine. We can go through cosine real quick. Cosine is the same idea. You still have the same angle measures. It's still 0, pi over 2, 3 pi over 2. Sorry, pi and 3 pi over 2. Right? Same angle measures. But the x coordinates are different this time. So when you do here, for the 0 input, right? Angle measure is 0. You're not rotating anywhere yet. The x coordinate is +1, right? So that's why when x is 0, y is +1 for the cosine. There's my dot. It's at its max. Then when you get to pi over 2, the x coordinate is 0. So pi over 2 is 0. Then at pi, it's -1, right? So at pi, it's -1. At 3 pi over 2, it's 0 again. So I kind of missed the mark there, but it should be here. Okay. And then lastly at pi, or at 2 pi, sorry, it's back to its max again, +1. So you see those points? So the good news is, when you graph all of your sine curves and cosine curves will look the same. They really will. The only way to know that it's right or that it's wrong is that these numbers are the right numbers. Okay? Because if a function starts at a different spot, you know when you shift a graph, it's not going to start in the same spot. Like if this shifts one over, it's going to start somewhere else. Does that make sense? So we need to figure out how to graph this, and so I'm going to show you, but those 5 points are the ones that are going to matter. Okay? So we're going to go through each one, by itself now. So let's go to the sine curve first. Alrighty, there's y equals sine x. Actually, we'll do this. Oops, I don't want to do that. I want to do that. Y equals a sine bx plus c plus d. Okay? So, I don't know if you noticed, but the unit circle, when you cut it up like that, no, Len. Stop sleeping.
Racist. He's awake.
You're like this. Anyway, on your unit circle, the circle gets divided into 4 pieces. But all those 4 pieces are equally spaced. Like this quadrant is not bigger than that quadrant. Okay, my graph it is, but you know what I mean, right? They're equally spaced. So what you need to do when you graph a sine curve is find those four quadrants on your graph. So you'll always have a left endpoint, a right endpoint, a middle, and 2 middles. Does that make sense? That makes sense. Okay.
Yeah.
Look,
Endpoint.
I just go.
Middle and 2 middles.
There's a left endpoint, a right endpoint, somewhere in the middle, right? That cuts into 2 pieces. That's like pi and 2 pi.
Wow.
But then I have to have 4 pieces. So there's 5 points. 1, 2, 3, 4, 5. But there's 4 pieces. And they're all equally spaced. That is always true. No matter how funky those letters get, that is always true. They will always be equally spaced. The question is, what will those numbers be?
I got you.
Yes.
It's going to be 5 and 2.
For the basic curve, you're going to have 0, 2 pi, pi, pi over 2, 3 pi over 2. But things can get tricky. Okay? So I just want to make sure you guys know that. So what I'm going to be teaching you is about these letters is to find the left endpoint. This is generic, okay? To find the left endpoint, which sometimes you're right, Joshua. Sometimes it's going to be 0. Those are the easy ones. But when you start shifting and I start changing B and C and D and A, the graph is going to start getting different, right? But it'll still have the same look of a sine curve. So we need to figure out how do we get these values. Because when I grade your quiz, and more importantly your homework, those values have to be accurate and people get them wrong all the time. And I don't know why, but they do. Okay? So bx plus c equals 0. Bx plus c equals 2 pi. This is your left endpoint. This is your right endpoint. Why? Because the standard left endpoint is 0. So you're trying to equate it always to the original, which is 0. The 2 pi, I guess you can figure that out now, right? Is always the standard right endpoint, right? It's always from 0 to 2 pi. 0, 2 pi. Okay? Now, we already know what these values are because we have the unit circle right here and we can pretty much figure it out. But the easy way to do this when you don't have that, so I don't need this anymore, this is all gonna make sense in 5 seconds, watch. Not 5 seconds, but you see what I mean. You're gonna take, if we claim that this is A, the left endpoint is A, not like that A, but just, what do you wanna call it? I don't wanna call it A because you're really gonna go crazy.
B.
No, because there's already a B. It can't be A, B, C, or D.
C.
F?
Call it M. J, I like J.
Okay, that's
Good
what.
job feeling it.
Okay. F, sure. You want to call it F? Go ahead. Starting at F and ending at G. I get in trouble when I use those letters. Because function notation is F of X, G of X, and then when you say both of them, you have F and G.
That's why I said J.
F and G. But if you say it real fast,
F and G?
F and G. Wow. Nice.
Oh.
Mr. Martinez, did you just say that?
I did not. You guys did.
It's on video.
You guys did.
It's
We
on
caught
video
you.
now. It's going on YouTube.
No, it's not. It's going
I'm
unlisted.
telling
Watch me.
Mr. Ritt.
Okay.
Thank
So
God.
anyway, this is how you get the other values. You take G minus F and divide it by 4.
That's gross.
It's real crazy. It's really not.
Understand it, Laura.
G minus F divided by 4. Now, we already know these values because they're easy. But I'm just going to show you that this formula actually works. So in this case, we know that it's 0 to 2 pi, right? So if I took 2 pi, subtracted 0, because that's what F is, and divided it by 4, I would get pi over 2. Correct? That means that each increment, each section, is pi over 2. Right?
Right. Yeah.
That's what it means. So now, I'm going to take this number, this wonderful little number here. So if you want to call this increment, if that's what you want to call it, like what is the increment, what is each section going to be? It's this formula right here, G minus F divided by 4. If F and G are the endpoints, okay? So now, you take this number, and you add it successively, what is that? Successively? Is that even a word? Okay, whatever.
No, I don't think.
It probably is. Okay, so you guys hate fractions, it's okay. So you're at 0, and if you add pi over 2 to 0, what are you going to get?
Pi over 2.
Pi over 2. That gives you this number. If I add pi over 2 to that, I have 2 pi over 2, which is
1 pi.
pi. If I add pi over 2 to that, I'm going to get 3 pi over 2. And if I add pi over 2 to that, I'm going to get 4 pi over 2, which is 2 pi. See how that works? So it's very systematic. That's why you can't go wrong. You just can't, unless you're just being crazy. You can't go wrong. All right? You do this little guy, you get your increment, and you add it to the left endpoint just each time, 4 times. In your case, 8 times, because you want to go to 2 periods. There's only 1 period. So if you keep adding it, you'll get the next period, right? I can add 2 pi and pi over 2 to get the next one, and the next one, and the next one, right? All the way to 2 periods. Yes? Okay. Once you do that, if you know what sine is, you know that its sine curve is always going to be 0. Yes, max, 0, min, 0. So the sine curve will start at 0. At the next point, it's got to be at its max. At its next point, it's got to be 0. At the next point, it's got to be min. At the next point, it's got to, you can just follow that 1, 2, 3, 4, 5. Those are the 5 steps that you need for sine. Write them down. Okay? A is the amplitude. Because the curve will bounce between two numbers. 1 and -1 in this case. If that amplitude becomes a 5 for some reason, it means that it's going to bounce between 5 and -5. Like it's just always the amplitude. Okay? The plus D, just like before, it shifts the graph up or down. Up or down, up or down. Okay? So now, we're going to replace this with cosine, but not much is going to change. This is going to change to a cosine. That's still going to be the same. This is not going to be this anymore, because a cosine starts at its max, 0, min, 0, max. A cosine starts at its max, then it goes to 0, then it goes to its min, then it goes to 0 again, then it goes to its max. Those are the 5 points for a cosine curve. But this is the same. The increment is the same. The plus D is the same. The amplitude is the same. Nothing changes for the cosine. Okay? So now I'm going to get to the nitty-gritty and actually do one with you that's not a basic one. And we'll start with something that's not too crazy, and then we'll get one that's really crazy like that. And by the way, the one on your quiz on your test, they're that crazy. It has everything. It has an A, a B, a C, a D. It has a whole shebang bang. But in your homework, the first ones are like just like one number, and they'll have 2 numbers, and then we'll have the whole thing. But they kind of start you off in stages. So anyway, yumminess. So I'm going to do,
Number 4.
no, not number 4.
Okay, number 8.
None of these are fun. They're just so boring. I'll do number 12. No, that's yours.
Let's
Never
do all the
mind.
ones that are on the homework.
You got 12.
12.
I
I'll
like
do
12.
14.
No, I like
12.
What's 14?
G of x equals 4 minus 2 sine of x.
One thing I hate about the book is how they put the 4 in front. So lame. D should be at the end. So if you want, you can just rewrite it as, really it should be negative 2 sine x plus 4. Because this is negative 2 sine x, negative sine x. This is positive 4, positive 4. But now it's in the right order. You know, it's a plus D. They don't usually put the D in front, okay? So there you go. First of all, my amplitude is not 1. There's not a 1 in front of the sine, so it's going to be 2. The negative, just like parabolas, when they're like positive x squared, negative x squared, the negative is definitely going to flip it around, okay? But that's going to move it 4 units up. So, this is what you want to do. I'm going to show you how easy this is. You're going to say, oh my goodness, I want to graph all day long. Okay, maybe not that crazy,
Never,
but
I'm never.
I know it. There, okay. So here we go. First of all, there's no bx plus c, right? There's no like b or c here. So that means that my left and right endpoint are still going to be 0 and 2 pi. Correct? I mean, if you really want me to go x equals 0, I can. Because b is 1, right? Yes, Holly?
Yeah.
You know what I mean? Like,
No, yeah, that's
so
what I'm saying.
it's going to be 0 and 2 pi. Just, okay. So my amplitude is going to be 4. So basically, when I do this, I'm going to put my 0 way down here. And the reason why I'm doing that is because plus 4, it means I'm going to be like 1, 2, 3, 4, right?
See.
And so this is gonna be my middle. So what I do when I have a D is I kind of draw an imaginary new like horizon, if you will. That's very crooked, but you get the point. Because I need something to do like the whole 0 thing, you know? And since it moved, you might lose track of where you are. So it's kind of helpful to have this like, it's not part of the graph, but it helps you keep things straight. So I'm gonna put that in there for my plus 4. The 2 tells me that I'm going to oscillate, bounce between 2 values above and below. So if I was at 0, that would be positive 2 and negative 2. But because I moved up, it's going to be 6 and 2. Right? So here's my 2, and that was 4, right? 5, 6. I'm going to label that. So it's going to bounce between these 2 values. Okay? And this will be my little center line right here. Okay? And then we're pretty much done, with the exception that we need to put our axis down here. We're going to want 2 periods. So what I do is I don't even like measure anything. I just say, okay, this is the end of my axis. I ran out of space. Yay. So this is going to be 4 pi. Because 1 period would go to 2 pi. So 2 periods would go to 4 pi. Right? So then I just go down the middle.
Wait, why are we doing 2?
What is it that says?
You always want to, when you graph, it's always going to say include 2 full periods. Okay, so they're going to want you to graph 2 full periods. 1 is not going to be enough. Okay, so because they're always equally spaced, I'm just going to, so it doesn't matter like if you know, your graph, you might like have less space, so you might only have this much space, but as long as your numbers are right, it won't matter. So I just did all of this to 4 pi, and then in the middle is a 2 pi. Pretty sure of that, right? So now this little piece has to be cut into 4 pieces. So middle, middle, middle. It's always the middle, so it's not hard to do that. You can even ballpark it. It doesn't have to be, you know, perfect. Middle, middle, middle. Right? And we already did this earlier. We know that the increment is pi over 2, right? So we're starting at 0.
It's always pi over 2?
No. It's not pi over 2 when you have a bx plus c.
Okay.
Okay, but right now it is. So now I'll do that one next. I'll do another one next, okay? So 0, pi over 2, pi, 3 pi over 2, 2 pi. Right? 5 pi over 2, 3 pi, 7 pi over 2, 8 pi over 2, or 4 pi. And we filled all that in. Now, the sine curve, we said earlier, is always 0 max, 0, min, 0, right? When you have a negative, that flips it around. So normally I would go 0, max, 0, min, 0. But because it's negative, I'm going to start down here and go this way. That's it. So I'm going to be at 0.
You just switch the
My
max.
min is going to be right here at that pi over 2. At pi, I'm back at 0. At 3 pi over 2, I'm going to be at my max. And at 2 pi, I'm right here. Connect the dots. And please don't make them V's. I don't want to see this like weird, okay? It's not a W, okay? Anyway, and so then over here, you're going to be at your min again, which is right about there. Then you're going to be at 0. This is going to be at your max again, and then at 0. So you're going to go, there you go. Now, my graph, obviously this is not straight, so kind of, you can see the gap got wider here. But, you have paper that, you have rulers, you can, make it straighter. But that's the idea. There's your graph. Yeah? Let's do one that actually has a B so you can see what I'm talking about with this whole fraction business. So let's, you want to do a cosine? Does it matter? Because aside from this sequence, graphing the cosine of this version would have been the same thing, only I would have started at a different, I started at the max instead of the, the 0. Does that make sense? So do you want me to do a cosine? I'll do a cosine. Let's do a cosine. Y, can you tell me what 27 says?
Y equals 1 plus 1/2 cosine pi x.
Okay, so now we have a pi in front of the x. And by the way, the period of the function, I should have said that earlier, the period is always 2 pi over b. 2 pi over b. That's the period of the graph. So far we've had nothing in front of the x, thus far. So our period has always been 2 pi, because 2 pi divided by 1 is 2 pi. But now we have a pi right there, right? So my period, when I try to find the period of this function, it's actually going to be 2 pi divided by pi, because b is pi. And what's it going to be? 2. Even easier. That means that it's going to go 1, 2. That's one period. Okay, so I'm going to do this little biz. It's my period. Okay, so where am I starting? Pi x equals 0. That's my left endpoint. But when I divide by pi, I still get 0. So I'm starting at 0 still. Yay! Where do I end? I'm going to say pi x equals 2 pi. And when I divide by pi on both sides, I'm going to end at 2. So I want 2 of these periods, right? So I have to go to 4, right? So bam, 4. Not 4 pi, just 4, the number 4. The middle of that is 2, correct? So now you need middle, 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 middle. This is a lot easier. But if you want to do the formula, we can. The formula says to take the 2, subtract the 0, divide by 4. And you get 1/2. So this is 1/2. This is 2 halves. This is 3 halves. 4 halves, which is 2. 5 halves. 6 halves, which is 3. 7 halves. 8 halves, which is 4. See, no pies. It's even better with no pies, okay? Even though pies are yummy, okay? We know that there's a plus 1. So it's going to shift, and because this is like a 1/2, I'm going to make my 1 like a larger like gap. So I'm going to claim that this is like 1, right there. And this is like -1. Normally, the graph would start at its max, and it would go bounce between these two numbers, okay? But now my 1 is going to be the middle. And I'm going to have to erase this little guy right here. I already did that, so who cares? Okay? So there's my 1. And the amplitude, the A, is 1/2. So I'm gonna go above to 1/2 and